Welcome back everyone for part 3 of these Homework 1 videos where we're talking about Chapter 1 material. We're seeing it all today because we're seeing word problems, we're learning about how to do things with whole numbers. Either we're learning it, I hope to be honest that we're not learning it, we are simply seeing it again. We will learn something right here though, is that there's a really nice formula that we're going to be seeing over and over again, which we will get to after I pronounce the name of this company, Dazzling Designs. So that one's already taken if you were going to use that for yours. They made custom drapery for a client using 60 yards of material. Now we're getting something over here. See how it says this thing $5 per yard? There's a name for this kind of a price. Do you know the name of this price, $5 per yard? It should be called the unit price, because this term unit, it gives you the idea of one, like for one of something. Because unit, you know, unicycle, it has one wheel. I'm trying to think universe. What does it mean, universe? Because it says uni. I don't know what a verse is though, as far as a universe. I heard some goofball on TV talking about a multiverse, but I think that he must be smoking something. And so the unit price is the cost for one thing, which in this case it's 1 yard of fabric. $5 per yard. What you do with a unit price, and we will see here our first formula for the whole trimester here, is that you have a unit price, which this is always going to have units like dollars per unit. So in this case per yard or whatever. We have a unit price. If we multiply it times the number of units, then we will get, if you think about it, the cost for each one times how many you have. We should get the cost for all of them. We will get the total cost. And it's so nice to explore the ramifications of these units over here. And in this case, I'm talking about this unit. I'm using unit with multiple definitions right now because there's a unit price, what we were just talking about, how it's one of something. And then we have units, which are what we use to measure things. Like here, dollars per unit, that is a unit, of course. Here, the total cost, this will be in dollars. And it's possible, maybe it's not so clear right here, but it's possible always to keep track of units even while you're doing these operations. You know, you multiply units. When you multiply numbers that have units, you multiply the units as well. And so when we go dollars per unit times a number of units, actually the units on bottom and the units on top, they will end up canceling because this unit happens to be in the numerator of a fraction. Getting a little bit ahead of myself because we're not talking about fractions yet, but I just want to prepare you. You want to get your mind thinking about fractions and how they work. But whenever we do this, perform this cancellation over here, the units will cancel on these ones. It just becomes only dollars left over. It can be very useful if you cannot remember a formula, or you cannot remember which order you should multiply or whether you should divide or what you should do. Think about the units, see if it will help you. But here, what do we have according to this formula is that we have 60 yards of material, $5 per yard. So it's going $5 per yard times the number of yards, which is 60 yards. And so we see yards on bottom, yards on top. It will cancel. It becomes over here, I would just write it $300. Now what if the company received 4 more orders of the same size? How much more material will be needed to fill the orders? They're getting 4 more orders of this same size, this size of 60. So it's 60 yards. I will just put some units here because we can always make units depending on what is the context of the problem. This is basically yards per order. 60 yards per order. And there are 4 more orders. So we are multiplying these. Orders will go away, it just becomes yards. 240 yards. And so that does it for that problem, but here we're moving on to some division. Do you remember about long division, how it works? Long division is such a nice thing. And we're going to have, in this case, since we're not talking about decimals yet, decimals are for chapter 3. And so we're going to use this thing over here. Can you remember what it is? This R. When we get there, I will jog your memory if you cannot remember. But I know that you can, and that you have remembered what it is by now. And so we're dividing 2050 by 41. Is it going to go evenly, do you think? I'm not sure that it's going to go evenly. It might. Why don't we find out? Of course, if we put a number right here, this is how many times 41 will go into this number. 41, though, it does not go into 2, so we don't put a number here. What about above this 0? If we put a number above the 0, it'd be how many times 41 goes into 20. But of course, 41, it cannot go into 20. If we put a number here, that's how many times 41 will go into 205. It for sure will go in there, but how many times? Do you see that it goes 5 times very nicely? Because already 40 times 5 is 200, so this number, it just works so well. And then we multiply the 5 times the 41 over here, and we would actually get 205. And then we would subtract them. We will get, what do we have here? 0 is the result of subtracting this. It goes like zeros all the way down. But normally we would just write the 1 0. And then at this stage we want to put a number here, but first we have to bring this one down. Consider what number we're working with. 41, how many times does it go into this number? Of course, it goes in there 0 times. And once we have a remainder of 0, which we would get by doing 0 times 41 is 0. We can subtract these, get 0. We have a remainder of 0. That was the key word. The R word we're looking for is the remainder. There's no remainder. It's remainder of 0. So actually 50 times. It goes evenly. How nice. And now we are thinking about dividing these numbers. 424 divided by 12. How are you feeling about it? Can you remember these steps that we should do? What is the first step? Of course, 12, it will not go into 4. But 12, it will go into 42. And how many times? Think about it. Can you count by 12s? Sometimes if you count by 12s, you can find how many times it will go into 42. Counting by 12s, it goes 12, 24, 36. Then the next one's 48. So 48, it overshoots this one. So actually 3 times was the 36. We subtract them. We can go through this process of borrowing, but 42 minus 36, can you just do the subtraction straight away? Sometimes it's very nice to do it. Or else we could borrow. See, instead of 40, we can make it 30, and we can make the 2 into a 12. 30 plus 12 is 42, so we can write 42 this way as well. But then 12 minus 6 is 6. 3 minus 3 goes 0, so we have the 0 over here. Now we're looking above the 4, but the 4 we should bring it down. Figure out how many times will 12 go into 64. Can you count by 12s with me? It goes 12, 24, 36, 48, 60, and then what comes after 60? 72. And so 72 is too much. That was 6 times. If you can count by 12s and go on your fingers as well. 12, 24, 36, 48. 60 was 5 times. And then we go minus the 60. So it goes 35 with a remainder of 4. Bingo, it's that one. Good job on these problems right now, guys. I hope that this long division is coming back to you very well. And that's going to do it for this video. We will have another video for the last few problems on here that we're going to look at. And thank you guys for watching. Catch you in the next one.